ए थिन मेटल डिस्क ऑफ रेडियस आर, ये एक मेटल डिस्क है और इसका रेडियस है आर। ये हम इसको ऊपर से देख रहे हैं। अगर हम इसको साइड से देखेंगे तो ये इस तरह की डिस्क हो सकती है, ये ऐसे, ये साइड व्यू है और ये टॉप व्यू है। जब हम इसको पानी में तैराते हैं, पानी में फ्लैट स्विम कराने लगते हैं, तो ये अंदर डूबती नहीं है। क्यों नहीं डूबती है? द डेंसिटी मस्ट बी लेस देन वाटर एंड इट फ्लोट इन दिस सिचुएशन। जब इस सिचुएशन में ये फ्लोट कर रही है, देन मेकिंग एन एंगल थीटा विद द वर्टिकल एज, वाटर सरफेस एंड द बेंड्स ऑफ सरफेस डाउनवर्ड. This is bent downward and this is water surface. Exactly at this point, this makes an angle theta with the vertical. ये एंगल थीटा बनता है। वाटर सरफेस, इधर से ये वाटर सरफेस एंड दिस मेक्स एन एंगल थीटा विद द वर्टिकल। ओके, ये हमने पानी में ऐसे डाली है इस तरह से। ओके, if the disk displays a weight of water W, ये जितने पानी को इसने डिस्प्लेस किया है, that weight of water is W. Okay, then the surface tension of water is T, then weight of the metal disk, इस metal disk का weight कितना है? Okay, उसके लिए हम कुछ नाम रख लेते हैं। weight of the metal disk, Wm. Now, this weight of the metal disk force is acting downward. Then why it is floating? Because there are certain forces acting on it, and there are two forces. One is upthrust by the water and upthrust by water, and other is, see here, this water surface try to become straight, it try to become the minimum surface area, and for that it is applying a force in this direction. If it is applying a force in this direction, we call it surface tension. If this is surface tension on both the sides, then it has two components. One is T sin theta on this, and this component is T cos theta. This is surface tension which is acting on every point, here, 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 every point. And it is trying, it is working in this direction, and the component T cos theta is acting on this direction. Then how much is the force? Here we will write force due to surface tension. Now, upthrust by water, that is given to us. Weight of water displaced is W, and upthrust is always equal to the weight of water displaced. So this we can write as W. Now the force due to surface tension. Force. What is the relation of force with surface tension T? And we know it is equal to surface tension multiplied by total length. Which length? Where it is applied. This is the line of disk where surface tension is applying upward. जैसे इसके चारों तरफ उंगली डाल के हम ऐसे ऊपर उठा रहे हैं। कितनी लेंथ को उठा रहे हैं? ये इतनी लेंथ को उठा रहे हैं। And how much is this length? This length is 2 pi r. So first I will write it the formula form, T into length, and then we will make it W plus T, 2 pi r. This is weight of the metal. Then weight of the metal is T into 2 pi r plus W. Now this T into 2 pi r is acting in this direction, and we have to take this component cos theta. So this is T cos theta into L, T 2 pi r cos theta, and let us see if it matches something. W plus T 2 pi r cos theta. So this is the right option we get here. Two soap bubbles A and B are kept in a closed chamber where the air is maintained at pressure 8 Newton per meter square. Here the pressure in the air is 8 Newton per meter square. The radius of the bubble A and B are 2 centimeter and 4 centimeter. 2, 4. Surface tension of the soap water used, surface tension S, is 0.4. 0.04 Newton per meter. Okay. Find the ratio NB upon NA. What is this? Where NA and NB are number of moles of air in the bubble A and B. Here, the number of moles Na, number of moles NB. This is A, this is B. Okay. Ratio NB upon Na. So what we have to find is NB upon Na. Now how this NB upon Na appear in this question? Do we remember? We remember many things. Like if there is a bubble, there is a excess pressure inside the bubble. Excess pressure. This is number of moles. Number of moles and pressure, where are they related? We remember gas equation, and the gas equation says PV is equal to nRT. Okay, now for bubble number 1 and bubble number 2, the air quality is same, but here the contents of air are more, so N will be different. Here contents of air, quantity of air is less, so NA is different than NB. Okay. Now R is a constant, temperature, both have got the same temperature. So this equation for bubble number 1 stands for pressure A V is equal to pressure A, volume of A, is equal to N of A RT. And for bubble number 2, that is bubble B, this is PB, VB is equal to NB RT. Now we have to find NB upon NA, this upon this. So here we have it, NB upon NA, and this is this divided by this. RT are cancelled, same. So what we get here is PB VB upon PA VA. Now PB VB, pressure inside the bubble is pressure outside plus excess pressure. याद रखिए, whenever there is a formation of bubble and the drop, then due to surface tension there is certain extra pressure because this film is trying to reduce its area, so it gives additional pressure inside, and that additional pressure is how much? That additional pressure is 4S upon R for the bubble. This is additional pressure. Addition to what? Addition to outside pressure, and outside pressure is 8. So the total pressure is 8 plus 4S upon R, and this R is for bubble number A. Bubble number B. I will write it B. This is the value of PB. Now VB, the volume of this is of course 4 upon 3 pi radius of B cube. This is to be divided by pressure A. So this I will write it 8 plus 4s radius of A into volume 4 upon 3 pi r and here A cube. This is NB upon NA is equal to. Now if we solve this, we get the answer. Okay, do we have the figures? Answer is yes, we have the datas. And it is 8 plus 4 into S. S is given to us 0.04. 4 into 0.04 to be divided by radius of B. Radius of B is 4 centimeter, and mind it, centimeter, and this we are taking as Newton per meter. So this is CG system, this is SI system, this must be converted into SI system. So 4 centimeter is equal to 0.04 meter. Okay. Into 4 upon 3 pi. Okay, I will write it this time. Next step I will cancel it out. RB again 4 centimeter, that is 0.04 cube. Again same way, same S for A. R is 0.02. 0.02. This is pressure into volume 4 upon 3 pi 0.023. Let us solve this. Cancellation. This is cancelled out. Here 0.4 is cancelled. 8 plus 4, 12. And this 12 into 4 into 4 into 4. 12 into 64, 10 to the power minus 6 to be divided by, and here it will be 2 into 4, 8, 8 plus 8, 16. 16 into 8 into 10 to the power minus 6. This is again cancelled. 8 8s are 64, 8 2s are 16, and 2 6s are 12. After all the cancellation, it comes to 6 by 1. NB upon NA comes to 6 upon 1, and this is our answer, 6. A capillary tube of radius r is immersed in water, and water rises in it to a height h. ये कैपिलरी ट्यूब और इसमें वाटर राइज हुआ है h. H is the rise of water. Okay. And this water in the capillary tube is 5 gram. Okay. Another capillary tube of the radius 2r. ये हमने एक और कैपिलरी लगाई और इसका रेडियस r था, इसका 2r है. अब इसको जब हम पानी में डिप करते हैं तो ये भी पानी को उठाती है, और हमसे पूछ रहे हैं इसमें जो पानी ऊपर उठेगा उसका अगर हम मास लेंगे तो वो मास कितना होगा. हाइट नहीं, मास. यस, this we have to find out. So there is radius, there is height, and there is mass. They are related to each other. क्या आपको इसके रिलेशन मालूम है? आंसर है यस। मास इज इक्वल टू वॉल्यूम into density, and volume is how much? Volume is pi r square into h. This is volume multiplied by rho. This is mass in both the cases. Okay, this formula. Then what is the relation of r and h? This is SN formula, that h is equal to 2 tension upon rho into r. This is the formula we have for height. Okay, supposing that angle of contact is 0. So that cos theta here is 0. Okay, this T stands for tension, surface tension. We can write it as, we can write it T. Okay. These are the two formula in our knowledge. Now we apply it in case 1. Case 1, height. H is given to us, R is given to us. Then what should be the mass? H is given to us, R is given to us, rho of the water we know very well. So this is mass in capillary 1. Mass in capillary 1 is pi r square into h into rho. And how much is T? What is common in the two? Radius? No. Mass? No. Height? No. If mass is not common, radius is not common, height is not common, then what is common which we can take help? Answer, surface tension is common, because both are using glass and water. So this tension is common. This. And this is tension is common, rho is common. Therefore, H is a function of R. That means H can be converted to the terms of R. In place of two unknown quantities, we will have only one unknown quantity, that is R, and this relation we know. Here it is R, here it is 2R. This gives us a hint that we must convert H into R. Okay, so this is how we think. Now M1 is equal to pi r square into H. H is 2 surface tension rho into R multiplied by rho, and this is equal to pi r t. Rho is cancelled, 1 r is cancelled, and we have it 2 pi r t. This is the formula for mass. Now you see, here is mass to the power 1, here is radius to the power 1. Means mass is directly proportional to radius. Tension in both the cases is common. So M1 is equal to 2 pi r1t and M2 is equal to 2 pi r2 t. Now M2 upon M1. M2 we have to find out, therefore we put it in the numerator. M2 upon M1 is equal to 2 pi cancel, t cancel, so R2 upon R1. And here R2 is given to us, R is 2R. 2R upon R, and M1 is also given to us. So M2 is equal to twice of M1, and M1 is given as 5 gram. M1 is 5 gram, 2 into 5 gram. So the answer comes to be 10 gram. This is how we make it. Read this question. A certain number of spherical drops of radius small r coalesce, combined हो जाती हैं सब. These are the drops earlier, और इन सब को हमने मिलाया और एक बड़ी ड्रॉप बन गई. इस सब का रेडियस r है इंडिविजुअल का, और इसका रेडियस कैपिटल R है. ये इसका वॉल्यूम V है. If T is the surface tension of the liquid, surface tension T है. Then energy. We have to find out energy is released. Energy is neither released nor absorbed. So, what will happen to energy when the small drops become a large drop? Okay, find out. Surface tension and energy, where are they related to each other? Is it extra pressure? Yes, of course. Extra pressure, change in volume, PV, that gives us energy. Any other form? Yes. These are having surface, and the surface energy, that is energy due to surface tension, is also given by a formula that energy is equal to surface tension, let us say T, this is to be multiplied by area. This is one formula, and there is another formula. This one we use because these data are available with us. Okay, now we will remember surface energy is surface tension into area. It has become very simple now. Surface tension in this case and in this case are equal. Let's calculate energy in this case. A certain number of spherical drops of a liquid of radius r coalesce to form a single drop of radius r and volume V. Okay. How much is energy with this? Energy with large drop. How many surfaces a drop has? 1 or 2? Answer is 1. So we will take one surface area only. One surface area only. So how much is the energy E with this? Surface area is 4 pi r square and the tension is T. 4 pi r square, and it has got capital R. 4 pi r square into T. This is the energy with it. Okay. Now, energy with this. Energy with large one. Energy with small. Energy with small is again T and 4 pi r square. 4 pi r square. Surface area, remember, we are not taking 4 upon 3 pi r cube, that is volume. Here surface tension is to be multiplied with the area, and area of the sphere is 4 pi r square. Okay. This is surface energy of one drop, but we don't know how many drops are there. Let us say there are n drops. So this is the total surface energy with these drops. Now n is another unknown number we are supposed to find out. How do we find out n? The answer is n together, n drops together makes a large drop. So we can always find out how much is n equal to. How to calculate n? The answer is very simple. The total volume of the n drops make one volume of this. So what is one volume of this? for n calculation. The volume of the large drop is 4 upon 3 pi r cube. This is equal to sum of n drops of small volume. Small volume is 4 upon 3 pi r cube. And here you get value of n. So n is equal to r cube upon r cube. What is n? The number of drops. Where do we want it? We want it here. Energy large, energy small. Now what is, let's put here. So now energy of small drops is equal to r cube into T into 4 pi r square. R square, this n is equal to r cube upon r cube. R. So smaller is r, more is energy. Okay, this right. So this is the energy of the small drops. This is energy of the large drop. Now, is it a gain or is it a loss? Energy of small, where is 4? Here is 4. I will write it again clearly, and this is 4 pi r cube, 4 pi r cube upon r into T. This is energy of the small drops, and this is energy of the large. Compare the two. T same, T को छोड़ दीजिए. 4 pi same. Now r square and r cube upon r, which one is larger? Of course r cube upon r is larger. देखिए r square दोनों में है, then it is r upon r extra. This r upon r, this r is much larger than this radius. Therefore, this quantity is a larger quantity. Therefore, energy with the smaller was more. Hence, E small is more than E large. There is loss of energy. Okay. If there is a loss of energy, we have to find out how much is the loss of energy. For how much is the loss of energy, we must make a minus and do it. Okay. Let's minus. What was the energy before? Loss 4 upon 3, and this is pi r, 4 upon 3 pi r cube upon rt minus energy of the large, 4 pi r square, 4 pi r square t. This is 4 pi r cube r t minus 4 pi r square t. Okay, this is loss of energy. Now, we have to solve it, and solve it in a manner that it match either of this. In this, what we see here, volume. Volume is 4 upon 3 volume R. Here it is given. So what is given to us? V is symbol to be used for 4 upon 3 pi r cube. Okay, we'll do that. Then in our answer T common is taken out of the bracket. We will also take it out of the bracket T. This 4 pi has to be taken out, 4 pi T. Now what else? R square. R square, but our answer is 1 upon R, so let us take R cube. And for the volume we will need 4 upon 3 pi R cube. So we take R cube out. Now what do we have here? 1 upon R minus. 4 is out, pi is out, R square is out, R cube is out. So if this is divided by R cube, we get 1 upon R. T is already out. Now here, if we want to convert this 4 pi R cube, let's divide it and multiply it with 3. 3 into 4 upon 3 pi R cube, 4 upon 3 pi R cube into T, and 1 upon R minus 1 upon R, and this is volume. 3 volume T 1 upon R minus 1 upon R. So we have this solution here, 3 volume T 1 upon R minus 1 upon R. Okay, so we get it here. This is the energy, and there is a loss. Loss means energy is released. So this is our right option. Okay. So let's go to the next question. Pressure inside two soap bubbles are 1.01, 1.02 atmosphere. Ratio between their volumes. Volume इनके अलग अलग हैं. एक का वॉल्यूम V1 और एक का वॉल्यूम V2. ओके, इनके अंदर जो प्रेशर हैं 1.01 एंड 1.02. बाहर कितना प्रेशर होता है? आंसर है बाहर होता है 1 एटमॉस्फेयर. सो दिस इज एक्सेस प्रेशर. हाउ मच इज द एक्सेस प्रेशर इन इट? In 1. This excess pressure is 1.01 minus 1, that is 0.01, and excess pressure in number 2 bubble, this is 1.02 minus 1, that is 0.02. These are the excess pressure. Now what we are supposed to find out? Ratio between their volume. Okay, ratio between their volume, that is volume 2 to volume 1. Volume 2, volume 1. How we should proceed? Which component of the volume can be related to pressure or to surface tension? Surface tension for both is constant. Excess pressure is different. Excess pressure depends upon radius and volume also depends upon radius. So we have to think about that particular quantity which relates the two. Volume is made of radius. Radius से volume बनता है और pressure का एक relation radius से होता है. इसलिए हम radius के language में इनका conversion करेंगे. So what is volume 2? This is the answer we want to find out. Ratio of volume. This gives the answer, and now this is 4 upon 3 pi R2 cube upon 4 upon 3 pi R cube. R2 upon this gives us the answer. Now we have to find the relation with P. Delta P1 is equal to 4 surface tension. Let's change the name, surface tension S. 4 into surface tension upon radius, and this is radius 1. Radius 1. This is equal to 0.01. Delta P2 4s upon radius 2. This is 0.02. Divide dividing what we get, R2 upon R1 is equal to what we are dividing. Divide 1 by 2. Divide 1 by 2. So this comes to R2 upon R1 is equal to 0.01, 0.02. ये दोनों स्टेप आपको समझ में आ गए. 1 upon R1 upon 1 upon R2, और उसको सीधा करेंगे. R2 will go to the numerator. 0.01 upon 0.02 this. Okay. Now R2 upon R1 is this, so make a cube of it. R2 upon R1 cube, or cube upon cube. This is 1 upon 2, and when we make cube of it, it becomes 1 upon 8. So here 1 upon 8. So what we get here, ratio of V2 to V1 in this, V2 to V1, R2 cube upon R1 cube, R2 cube, R1 cube, this comes to 1 upon V2 upon V1 is 1 upon 8, so V1 upon V2 is 8 upon 1, 8 to 1. This is V1 upon V2, 8 to 1, 8 to 1. V1 upon V2, ratio of their volumes. Okay, so this is how it's made. A wooden stick 2 meter long is floating on the surface of water. The surface tension of water, okay, is so much. There is a stick, और उसको हमने ऐसे पानी में डुबाया. जब उसको पानी में डुबाते हैं, ये साइड हमको दिखता है. So I am drawing only this. पूरी स्टिक ऐसे है. सरफेस टेंशन कहाँ काम करता है? इसको जब हम पानी में ऐसे डुबाएंगे तो ये वाली जो लेंथ है, ये पूरे लेंथ में बॉर्डर बनेगा. ये वाटर के मॉलिक्यूल और ये सॉलिड के मॉलिक्यूल वुड के, और ये दोनों आपस में ऐसे मिले. जब ये दोनों ऐसे मिलते हैं तो पूरी सरफेस में ये ऐसा, साइड से देखिए, साइड से ये व्यू हमको दिखा, और यहाँ से सरफेस टेंशन ऐसा इसको ऊपर खींचता है. क्यों? क्योंकि ये जो सरफेस ऐसी बड़ी हो गई है पानी की, ये सरफेस अपने आप को छोटा करना चाहती है. सो देयर इज एन एंगल ऑफ कॉन्टैक्ट एंड देयर इज ए सरफेस टेंशन विच इज एक्टिंग अपवर्ड. अब सरफेस टेंशन कितना है? इन्होंने दिया है 0.07 न्यूटन पर मीटर. ये पर मीटर क्या है? ये जितनी बड़ी सरफेस है जो कांटेक्ट में आती है, यहाँ पर सरफेस टेंशन ऐसे काम कर रहा है, ऐसे ये इस तरह से सरफेस टेंशन जो इसमें काम कर रहा है, ये इधर, दिस इज 2 मीटर. तो टोटल फोर्स कितना हो जाएगा? 0.07 न्यूटन पर मीटर. 0.07 न्यूटन, 0.07 न्यूटन. ये इसको ऐसे उठाता है दोनों तरफ. इस तरह से ये यहाँ पे वाटर में फ्लोट करता रहेगा. ओके, नाउ इसके एक साइड में हमने सोप लगा दिया. सोप लगा के अब इसको पानी में डाल दिया. नाउ दिस सोप वाटर, द सरफेस टेंशन इज डिक्रीज्ड. अगर सरफेस टेंशन डिक्रीज हो गया तो इधर लगने वाला फोर्स भी डिक्रीज हो जाएगा. अब यहां पर कितना फोर्स लग रहा था? 0.07 प्योर वाटर. यहां पर उठाने वाला ऐसा फोर्स कितना लग रहा है? 0.06. 0.06. दिस इज सरफेस टेंशन ऑफ द सोप वाटर. अब इस बॉडी में इधर 0.07 फोर्स लग रहा है, इधर 0.06 फोर्स लग रहा है. देयर इज ए डिफरेंस इन द फोर्स एंड दैट गिव्स अस ए रिजल्टेंट. वी कॉल इट नेट फोर्स, एंड दिस बॉडी will be under effect of a net force. कैन यू एज्यूम ये नेट फोर्स क्या करेगा? ओके, इट्स नॉट इन द क्वेश्चन, पर नेट फोर्स के लिए हम लोगों को याद है कि नेट फोर्स हमेशा एक्सेलरेशन पैदा करता है। तो एक्सेलरेशन अगर पैदा होगा तो क्या ये वुडन प्लैंक मूव करना शुरू कर देगा? नो, हमने तो कभी ऐसा देखा नहीं कि एक तरफ आप साबुन लगा के पानी में डालिए और ये एक तरफ जाना शुरू कर दे। आंसर इज नो। वी हैव टू फाइंड आउट डायरेक्शन ऑफ द रिजल्टेंट फोर्स। यहां पर फोर्स ऊपर काम कर रहा है, यहां फोर्स ऊपर काम कर रहा है, ये फोर्स बड़ा है, ये फोर्स छोटा है, तो नेट फोर्स इधर का ऊपर की तरफ ज्यादा बना, इसका कम बना, तो ये बॉडी हल्की सी ऐसे हो जाएगी। दिस विल बिकम लाइक दिस। और जब ये पानी के अंदर जाएगा तो ये नेट फोर्स के कारण ये सिरा ऊपर और ये सिरा नीचे। अगेन वी विल सी द upthrust here will be more and the net forces will the total forces on the both sides will become equal. Okay, so as soon as we put soap here, there is a decrease in the force. Now how to calculate the force? Force is equal to surface tension multiplied by the total length on which surface tension is applied. So on one side it is surface, this is 2 meter long. On one side it is 0.07. On the other side it is 0.06. What is the difference? Force here is force on water side T into L. 0.07 into 2, force on soap side 0.06 into 2, net force 0.07 into 2 minus 0.06 into 2 is equal to 0.02 Newton. This is the net force. A drop of water is placed between two parallel glass plates which are then pressed together until the water film become 0.01 centimeter thick. If area of the water in contact with either plate is 10 centimeter square, then force due to surface tension drawing the plates together is so much. Surface tension of water is given. आपने देखा होगा एक कांच की प्लेट के ऊपर हम कुछ बूंद पानी की डालें, दूसरी कांच की प्लेट रखें ऐसे, और अब हम इन दोनों को अलग करना चाहते हैं, पर ये दोनों चिपक जाती हैं। अलग करने के लिए हम ऐसे स्लाइड करके तो अलग कर सकते हैं, पर अगर ऐसे अलग करना चाहें तो नहीं कर सकते। क्या सिचुएशन है वो सिचुएशन ऐसी है, देखिए वो सिचुएशन इस तरह से, ये ग्लास की एक प्लेट है, ये ग्लास की दूसरी प्लेट है, इन दोनों के बीच में हमने पानी डाला और पानी डालकर हम इसमें फोर्स लगाते हैं, इसको ऐसे इस डायरेक्शन में, तो ये सेपरेट नहीं होता, हमको ज़्यादा फोर्स लगाना पड़ता है। क्यों? इसके बीच में जो वाटर मॉलिक्यूल हैं वो वाटर मॉलिक्यूल ऐसा फैलने की कोशिश करते हैं और यहाँ पर ये सरफेस बन जाती है। दिस इज हाफ स्फेरिकल सरफेस, और लंबा होगा तो हाफ सिलेंड्रिकल सरफेस, यहाँ ऐसे दोनों तरफ बन जाती है। अब जब हम इधर फोर्स लगाएंगे तो ये सरफेस ऐसी इंक्रीज होना चाहेगी और सरफेस टेंशन सरफेस को इंक्रीज होना अलाउ नहीं करता। इसलिए सरफेस टेंशन इसको खींचकर छोटा रखना चाहता है, हम इसको खींचकर बड़ा करना चाहते हैं। दैट इज व्हाई वी नीड टू अप्लाई द फोर्स। ये तो रीजन हो गया। नाउ हाउ टू कैलकुलेट दिस फोर्स? जब हम इसको फोर्स लगा के इस तरफ ले जाते हैं तो ये सारे मॉलिक्यूल एक दूसरे से दूर होने लगते हैं और दूर होने के कारण यहाँ का प्रेशर डिक्रीज हो जाता है। Whenever we are trying to pull it, the molecules are trying to move away and the pressure here decreases. Decreases in comparison to what? Earlier the pressure here was 1 atmosphere. Now when we push it, there is a slightly less than 1 atmosphere and this volume is at less pressure. This is at normal pressure. Now compare the two. If we compare the two, this has got excess pressure. This pressure is an excess pressure over this pressure. And this is a normal pressure, but that means this pressure has become less. जिसको हम कहते हैं इनके बीच में वैक्यूम क्रिएट होता है, इसलिए ये ऐसे अलग नहीं हो रहा. फाइन, दैट्स ट्रू. तो यहां पर एक एक्सेस प्रेशर क्रिएट होता है. ओके, अगर हमको ये पता लग जाए कि ये एक्सेस प्रेशर कितना है, व्हाट इट विल टेल अस, व्हाट इज द डिफरेंस ऑफ द प्रेशर बिटवीन द टू. और उस डिफरेंस के कारण हमको ये फोर्स लग रहा है. और फोर्स की कैलकुलेशन प्रेशर से हमको करनी आती है. फोर्स इज इक्वल टू प्रेशर मल्टीप्लाइड बाय एरिया. और ये कौन सा प्रेशर है जो यहां हमको लगाना पड़ रहा है, कितना, एक्सेस. सो फोर्स इज इक्वल टू एक्सेस प्रेशर मल्टीप्लाइड बाय एरिया. अब एक्सेस प्रेशर यहां कितना होगा. एक्सेस प्रेशर का फॉर्मूला, एक ड्रॉप में एक्सेस प्रेशर 2T/R होता है एंड दिस इज हाफ ऑफ द ड्रॉप. पूरी सरफेस होती तो ऐसा टेंशन क्रिएट करती 2T/R. आधी कितना क्रिएट करेगी, 1T/R. सो T/R इज द एक्सेस प्रेशर मल्टीप्लाइड बाय एरिया. विच एरिया, दिस इज द फोर्स and here is the pressure. This is low pressure. So all this area multiplied by this low pressure is pulling inside and we have to apply the force outside. How much is this force? This excess pressure, change in the pressure, because here atmospheric pressure is pushing it inside. Here the pressure is less. So this excess pressure creates force, excess pressure into area, and excess pressure we have to take T/R because this is half of the drop surface. So now we can take the values. T, tension 75. Radius of this thickness is 0.01. So half of this is 0.005. This is area 10 centimeter square. So now this comes to 7.01.005. Correct. 75123. (150 into 10 to the power 4, that is 1000 times. This is force. This force is Newton. If we want to convert Newton into mass, that is the weight force, then we can convert it into mg. How? F in Newton is equal to mg. The value of G is 980 dynes, that we can take approximately 1000. So this we can write as G and this is 150 G. So the force is 150 gram weight. What is this? G stands for gram. And what is the weight unit? Weight unit is mg is equal to this. So m into g is equal to force. We can write as force. We can write it so many dynes or so many gram weight. Okay, these are convertible to each other. So our answer is 150 gram weight, and here is 150 gram weight. This is the right option, 150 gram weight. Okay, see this.